acting in the downward direction. And another will be the tension force on this mass in this direction. Okay, another will be the tension force. No problem. Okay. And remember that if a force passing from the axis of rotation or the point of the rotation, then torque due to that force equal to 0. So now see, this tension force is passing from the axis of rotation or point of rotation. So torque due to this tension is equal to 0. Now the torque on the mass, the torque on this mass is due to only mg. Due to only mg. Now what is the torque? What is the torque? So torque is given by, either you can write force perpendicular and the distance, or you can write force into perpendicular distance. Two meanings are there. Now you can see this is a force, and now you can take the perpendicular distance from the axis of rotation. That will be the torque. That will be the torque. And remember, this length is given as 1 meter. Length of the string from O to M is 1 meter. This point, this is also given in the question. Okay, this is given in the question. This is 1 meter. Okay, no problem. We can either write perpendicular force multiply R, and this we can write. So basically, how we will solve? This is mg, na? This force is in this is the force, direction of the force. Now take the perpendicular distance of this force. Take the perpendicular distance of this force from the axis of rotation. Okay. Now this force is in this direction. This force is in this direction. The perpendicular distance will be this. This will be the R perpendicular. You are not taking R, you are taking the R perpendicular. If you are taking R, R will be this value. Okay, so R perpendicular you will take. You are taking me. So can we find from this triangle R perpendicular? So R perpendicular value will be, this is 1, and along this direction the this will be 1 cos theta and this will be 1 sin theta. So it will be 1 sin theta. 1 sin 30 you can write. So now you can find the value of the torque, that is mg into 1 sin 30. Okay, so your answer is, this is m into g, sin 30 is 1 by 2. So the torque will be mg by 2. And what is the unit of the torque? Newton meter. Because torque is force and distance, so Newton and meter. Is my voice okay, na? Dangi?
Yes, sir.
Now another way to, means there will be the situation where from both the ways you have to find the answer. There will be the situation. So another way to solve this question means, of course, torque is a vector quantity. Torque is a vector quantity. Torque is a axial vector, like we have force. Force is a polar vector. Like angular velocity is the axial vector. Angular velocity, angular displacement, torque, angular momentum. These all are axial vectors. And when we are using these torque and all that, when there is a rotation like thing. So basically, torque is a cross product of R cross F. In vector form, the torque is written like, torque is represented by tau, that is R cross F. In the earlier classes, I have already discussed this. Okay, by the way, we want to solve this question. Okay, so mg is acting in this direction. So what you will do now, what you should do now, you should just do this, and I am not able to make this. Actually, this line should be. What we should do, this extend this line like this. If this angle is 30°, then what will be that angle? If uh, if this angle is 30°, can you tell me what will be this angle? This angle?
30°.
Very good, 30°. This angle will be also 30°. So I can write 30° here, 30°. No? So I can write here also 30°. So if this is 30°, now we can take the components. Now we can take the component of this mg. Okay. Now in this direction, I am taking the component of this mg. So it will be mg cos of 30°. And there is a one perpendicular component like this. A component in this direction, perpendicular in this direction, the component. Okay. Perpendicular to not this mass, perpendicular to this distance, perpendicular to this is not looking here. So basically this force will be perpendicular to perpendicular to this. Okay, this is the one another component, that is mg sine 30. Mg sine means now you have just splitted this vector in two directions, so there is no requirement of this. Now you will see the effect. This mg sine 30 is along this line, and this line is passing from. Okay, so torque due to this mg cos 30 will be 0. Now you can write this is your r, and this is your force perpendicular. So you can apply here r into force perpendicular, r into force perpendicular. So what is r? R is 1 meter. What is force perpendicular? Mg sine 30. So again you will get mg by 2 your answer. Here what you have applied? Here what you have applied? You have applied just r perpendicular multiplied by force. So both the methods you should know, because in the question there can be the requirement of both the questions. Now you can just note down, please. When I am explaining one question, that is not the one question, that is whole concept. That is whole concept. Hmm. Okay. So after this, we will discuss the static equilibrium. Static equilibrium we will discuss. Okay, just write down and after that tell me, can there be the motion of the body if the net force on the body is zero? Net force on the body is zero. Can the body perform motion? Then,
Yes.
so I am just saying, if net force on the body is zero, can the body perform the motion? Can the body move? Just think. Yes or no? You can just say yes or no. For example, just see. If this is a pen, uh, is someone is applying a, now this time this pen is not moving. Why this pen is not moving? Because there is one force in this direction, means in this direction, and there is one force in this direction, means two equal and opposite forces are acting on this pen. So the net force on the pen is zero, and this pen is not moving. But if I say that mm, I cannot do that properly, so if someone is applying a force on the edge of the pen in this direction, and another person or applying and another force you are applying like this in this direction, but the line of the action of the force is different. Earlier the line of the action of the force is same. Now the you have changed, this is the line of action of one force and this is the line of action of another force, but both forces are equal. What will be the net force on the body? Zero. The net force on the, but the body will start rotation. But the body will start rotation. So it is not necessary that if the force on the body is zero, that it will not move. It maybe it will not move, but the body can move. And the body will not move in the condition when the force on the body is along the line of, means line of action of all the forces is same. If you are changing the line of action, so if on changing the line of action, what happens? The if even if the forces are equal, then there will be the torque produced. Torque produced and torque. What the torque do? Rotation. So for the body to be completely in equilibrium, for the body to be completely in equilibrium, the net force on the body must be zero and net torque on the body must be zero. So that is the condition of the static equilibrium. Okay. So static equilibrium, translational equilibrium, translational equilibrium. In the translational equilibrium, net force on the body is equal to zero. Okay, just wait for 2 minutes. Okay, so body will be in static equilibrium. Net force on the body is equal to 0. Okay, net force on the body is equal to 0 and net torque on the body is equal to 0 also. Then only the body will be in equilibrium. Net force on the body is equal to 0 and net torque on the body is equal to torque on the body is equal to 0 means the body is in the rotational equilibrium. The body is in rotational equilibrium. Okay, and if net force on the body is 0, so you can just conclude from the Newton's second law. Acceleration of the center of mass is equal to 0 and velocity of center of mass is equal to 0. So force in all the direction on the body must be 0 if net force is 0. Another rotational equilibrium means net torque on the body is equal to 0. If torque on the body is 0, means the angular acceleration on the body is 0. We will study later. And if angular acceleration is 0, then angular velocity is constant. So body can rotate with angular means constant angular velocity. So okay, so torque along the x-axis, y-axis, and z-axis should be 0. So basically, these 2 points you should note. For static equilibrium, net force on the body is equal to 0, net torque on the body is equal to 0. Now, question. This is the question. Lots of question you will get from this topic. This is a rod. This is a rod, and this rod has a length of 100 centimeter. Okay, and there is a mass placed on this rod here at a 40 centimeter. And this rod is attached with 2 strings, and those 2 strings are attached with the roof, or you can say surface, and this surface is a fixed surface. This mass is of 5 kg, and the mass of the rod is 10 kg. Mass of the rod is 10 kg. Acceleration due to gravity is given 10 meter per second square. They are saying system is in equilibrium. Find the value of T1 and T1 and T2 mean the tension in the string. Okay, we have to find. So what we will do? So we will take the rod. We will take the rod and we will see what forces are there on the rod. Okay, what forces are on the rod. This is mass m now, and this, what is the value of this mass m? 5 kg. So in this direction, on this rod there is a force of 5g. And one more thing here, this rod is having a mass of 10 kg, and this rod is of length 100 centimeter. So where will be the center of mass? Where will be the center of mass of this rod? If I am saying this pen is of 10 centimeter, so where should be and this pen is of uniform density. So what can you say? Uniform material. What can you say about the center of mass? Where will be the center of mass of this pen should be? If this pen is of 10 centimeter, just tell me.
At 5 centimeter.
Yeah, fine. 5 centimeter. So 5 centimeter means this is of 100. So here will be means I think 50 centimeter. So here will be the force of 10g. And remember the distances, because we are calculating the torque, so distances will will play an important role here. So this distance is 40, and what is this distance? This distance is, what will be this distance? 50, na? This will be 50 centimeter. Any other force on the rod? Just apply your mind. Means I can solve this question, but try to think. Means can there be any other force on the rod? These are the strings also. So on this rod, there will be tension like this, T1 and T2. Okay. So we can just draw the free body diagram of this rod like this. We can remove all the unnecessary things here from here. This rod is of 100 centimeter, we already know. This is already know. This is 40 centimeter. And this whole length is of 100 centimeter. Now, 4 forces are there on this rod. 4 forces are there on this rod, and suppose this is point A, this is point A, and this is point B. This rod is in equilibrium. This whole system is in equilibrium. So if this whole system is in equilibrium, then what can you say? You can say that net force on the rod is equal to 0. So net force on the rod is equal to 0 means you can say T1 in upward direction and these two forces are in downward direction. So you can say T1 plus T2 is equal to 10G plus 5G, 15G, and G is 10. So what will be T1 plus T2? 150. Okay, T1 plus T2 is equal to 150. This is your equation number 1. Now you have only equation 1, but you want to find 2 variables. So means for finding the 2 variables, there must be 2 equations. So another equation you will get from this: net torque on the rod about any point is equal to 0. About any point is equal to 0. Net torque on this rod about any point is equal to 0. So you can choose any point. I am just saying that I am just considering torque at, if I am calculating torque at A point, about torque on this rod about A point, that is equal to 0. Torque on B point, that is also equal to 0. Torque on any point on the body is equal to 0. So I am taking torque about point A on this rod, net torque about point A. We can write net torque about point A is equal to 0. Why I am doing this? Because one variable will be removed, you will see. Okay, one variable will be removed. Now you can see here, due to this T1, there will be no torque because this T1 is passing from the point. So now with this 10G, what will be the torque about point A? 10G into 15 centimeter. 10G into 15 centimeter. So you can write, and what will be the direction? Direction will be clockwise. Direction will be clockwise. So clockwise torque we will take negative. So it will be minus 10G into 50. And by this 5G, what will be the torque about point A? 5G into this 5G from here is at a 40 centimeter. So this distance will be 60 centimeter. So 5G into 60 and negative 5G into 60. Okay. Now due to this tension force, the torque about point A, T2 into 100, and this will be in anti-clockwise direction. T2 into 100, and anti-clockwise torque we take positive. T2 into 100, and this is whole is equal to 0. Now we can calculate it. This will become 10g into 50, and this is 5g into 60. So it will become minus 10 into 10, 100. This 10 and this is 10 into 50. You can write this 5 into 10 into 60 plus T2 into 100 is equal to 0. Now you can remove 10, or you can remove, I think, 100. Na? You can remove 100. So if you will take the 100 common, or minus 100 common, if you can take, so here you will have 50, and here you will have I think plus 30, na? And here you will have, I mean, this is the equation, you can solve it easily. Here you will have only plus T2, or minus T2, sorry, minus T2 is equal to 0, and this 100 gone. So we will have T2 is equal to 80 Newton. T2 is equal to 80 Newton you will have. Now if you have T2 from the equation 1, you can find T1. T1 will be T1 will be 150 minus T2 from equation 1. So 150 minus 80 will be 70 Newton. Got it?
Yes, sir.
So in this way you have to, now you can just see, due to this force the torque, and you are just calculating the torque about the point A. So means the torque is anti-clockwise, torque is clockwise. Do you know how to identify the direction of the torque? Means in the last classes I just taught. If I am saying suppose this is a force F, okay, and I want to find the this distance is R, and I want to find the direction of this direction of torque about point A. Okay, this is suppose this is a rod. This is a rod, and a force is acting at this point. Can you tell me what will be the direction of the torque about point A? Clockwise or anti-clockwise? So I will tell you how we can just find the torque, direction of the torque. So what you will do now in this case, just extend R. Extend R. Okay, extend, you have extended the R. So this is the R. Now move R to F. When you are moving R to F, the direction is clockwise. But this is not the exact direction of the torque. Remember, torque is the axial vector. So the direction of the torque will be along the axis. But for calculating for deciding whether the negative or positive, for the equilibrium condition, we take clockwise or anti-clockwise. Now another example. This is a force acting, and you want to find and this is R. This is the distance, and this is the force. This is point B. Can you tell me what is the direction of the torque in terms of clockwise or anti-clockwise? You have to tell about the point B due to this force F. Clockwise. Right. What you have done? You have just extended this R. Okay, this is R, and you will move R to F. Simply. But exact direction is given by right hand rule. So okay. So next question now. This is not very, this is a good question, I will say. Now see, a force is acting like this, and this is a cubical block. This is a cubical block, and a force is acting like this, and mass of this block is 2 kg. G is this. Coefficient of friction between the surface of the block and this wall. This is a wall, you can say, is 0.25. They are asking what is the torque about the center of mass. What is the torque about the center of mass produced by normal reaction? Produced by normal reaction by wall. And also they are saying body is at rest. Okay. They are saying body is at rest, but you have to find the torque by the normal reaction. Normal reaction. Torque about center of mass. For defining the torque, there should always be the point or axis should be there. Without the point or axis, the torque we cannot define. Okay, so we will see here what is happening. So, okay, this force is acting, and this is the center of mass, and this force is passing from the center of mass, and the center of mass will be at a distance of, you can now see where will be the center of mass. Okay. So, what forces will act on this? One force will be mg like this, mg. So, what will be the mass? Mass is 2 kg. So, 2g will be in this direction. 2g will be in this direction, and there will be a normal reaction. Now, don't say that normal reaction will pass from the center of mass. Okay? It is not necessary all the time. So, normal reaction will be like this, in this direction. This will be the normal reaction, and this normal reaction is provided to the block by this ball. So basically, this is a free body diagram of the block, not the ball. So we can remove this ball. Okay, and there will be one more force. There will be one more force. Can you tell me what force will be that? Friction force will be there. Very good, very good. Friction force will be there, and the direction of the friction force will be in the opposite direction of the tendency of motion. Thus, this block will have the tendency to move in this direction. The friction force will in upward direction. Okay, so friction force will be like this. Okay, so tangentially act na friction force like this. In this direction, there will be the friction force here. Okay, they are saying the net force, the body is in equilibrium. Body is at rest. Body is at rest. Body is not moving. So body will be in equilibrium. Body is in equilibrium. So the net force on the body is equal to 0. F net is equal to 0. So we will see what is the F net. F net means along x direction or y direction, the forces must be equal. So you can say this friction force is equal to 2g. You can say this friction force is equal to 2g, and 2g means 2 into 10 is equal to 20 Newton. No problem. And this friction force is given by mu into n, and that is equal to 20. Okay, friction force is coefficient of friction into normal reaction. Okay, so now normal reaction you can find from here 20, it will be 0.25. So 0.25 normal reaction will be 80 Newton. Okay, 1 by 4. So it will be 80 Newton. Now normal reaction we have find it out. Okay, we have the normal reaction now, and in the question they are asking torque produced by the normal reaction about the center of mass. Means about this point we have to find the torque due to normal reaction. Means the normal reaction is acting like this, you can see normal reaction is acting like this. Means here like this, the normal reaction is acting 80 Newton of normal reaction is acting, and there is a point here, there is a point here, and this distance will be, because this is a cubical block, so this distance will be 1 centimeter. But we do not know this distance. So suppose this distance is x. Suppose this distance is x. So how we will find x? But we have to find the torque due to the normal reaction. So we can just say that as this body is in equilibrium, so net torque on the body is also 0. Net torque on the body is also 0. Net torque on the body is also 0. So we can say the net torque means on the body is equal to 0. So now see what will be the torque. So due to this force, as this force is passing through the center of mass, so torque due to this force is equal to 0. As this weight also passing from the center of mass, again the torque due to this about the center of mass is equal to 0. Now this friction force is acting in this direction. Due to this friction force, and this distance is what? This distance is 1 meter, 1 centimeter, 1 meter. I think it will be. It will be 1 meter. It will be 1 meter because this is the center of mass. So due to this torque, due to this friction force, there will be a torque, and that torque will be F into 1. That will be F into 1, and the direction will be clockwise. The direction will be clockwise. So you can take this as negative. The direction will be clockwise. Now the torque due to normal reaction. The torque due to normal reaction will be normal reaction into this distance. Suppose the distance is x, you can take n into x. Okay. So how you will decide the direction? So the direction of this will be clockwise, anti-clockwise. Okay. The direction of this will be anti-clockwise. Okay. So it will be plus nx, and this is equal to 0. And what is this nx? That we want to find torque due to normal reaction. So if you will not consider x also, then also your answer will be correct. You can write here like this also. Torque due to normal reaction is equal to 0. We want to find torque due to normal reaction. Torque due to normal reaction, that is equal to F into 1 is equal to F. And what is the value of the F? 20 Newton. F is equal to 20 Newton. Now there is no requirement of this N and all that. You can just simply solve in this way also. Okay. If they can ask what is this distance x, what is this distance x, if they are asking, then you can just, there is a requirement of this. Okay. Then you can just say this will be minus F into 1. Torque due to normal reaction will be positive. This will be N into x, and this is equal to 0. And this is minus F. So it will become Nx is equal to F, and F is equal to 20. And N is given as, what is the value of N? N is 80. N is 80, and this is x. This is equal to 20. So x is equal to 20 by 80. Okay. So it will become 1 by 4 means x is 0.25. So 0.25 meter. So if they are asking x, then you can also find the value of x. So this will be the value of x. What is this? 0.25 meter. Understood?
Yes, sir.
Okay, so here I have applied net torque on this body about the center of mass or any point is equal to 0. Is equal to 0. So I am talking about the torque about the center of mass is equal to 0. Okay, so now you can just note down this question, and this question is quite good, I will say. It is given that no, the body is at rest, means the body is in equilibrium, means net torque and net force is equal to 0. Completed.
Yes, sir.
If they can also ask you the value of the x, so in that case you can do that way also. So just complete it, and then we will discuss the moment of inertia. So talking about the movement of inertia, na, like in the linear motion, we have, okay, first note down, then we will discuss. This NR means torque due to normal reaction. Okay, completed. Should I move? Okay. So you can just only write D in the chat box. Okay. Now after we have the moment of inertia. One more thing I want to tell you. What is moment of inertia? Very simple. In simple words, what is moment of inertia? Uh, if there is a mass, okay, if there is a mass and this mass is rotating about, if you can say this mass is at a distance of r, perpendicular distance, but this distance should be perpendicular distance, and this is the axis. This is the axis. So the moment of inertia of this mass about this axis will be mass into r square. Mass into r square. So talking about the unit, so unit will be kg into meter square. Simple. Another thing. Now how we will compare the moment of inertia? From where we get the moment of inertia? The question is that. Okay. So if suppose this is a mass m and I have just applied a force. Okay, just suppose here is some mass and I have applied a force like this. Here is some mass. Just imagine. I have applied some force. So what will happen? Uh, there can be the condition in which the mass can rotate also. There can be the condition. So that condition we are talking. So I have applied a force. This mass, if I will apply a force, if there is net force on the mass, so there will be the acceleration on the mass. So I can say that force on the mass is equal to mass into acceleration. Okay, fine. Now what you should do, just multiply both sides with r, with this r. R is the radius in which this mass is just revolving or rotating. It will become r into f. It will become r into ma. R into ma. Okay. Now what will be r into f? R into f will be torque. What will be a into r? That is mm, 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 just a minute. Huh. Okay, it is fine. So R into F is torque. Torque is equal to force into perpendicular distance. Here, this is torque. And R here is M, here is A. Now Rm, this A can be written as R into alpha. Angular accel in terms of the angular, what is angular acceleration? R alpha. So this torque you can write mr square into alpha. Now compare this equation and compare this equation. This is the equation of linear motion. This is the equation of rotational motion of the mass. Now force is equal to mass into linear acceleration. Torque is equal to moment of inertia into angular acceleration. So you can say that in linear motion, the role played by the mass is same as that of role played by the moment of inertia in the rotational motion. What is this mr square? Mr square is the moment of inertia I into alpha. Moment of inertia we will represent with small capital I. Okay. Now you can just understand in linear translational or linear motion you have the linear displacement, rotation, angular displacement, linear velocity, angular velocity, linear acceleration, angular acceleration, force, torque, mass, moment of inertia. If you want to calculate the moment of inertia of more than one masses, if more than one masses are there and distances are given perpendicular, this is the axis, and about this axis if you want to find the moment of inertia, then it will be m1 into r1 square plus m2 into r2 square plus m3 into r3 square. And remember, this moment of inertia is a scalar quantity. Scalar quantity. Okay, so just write down fast. Write down fast. In rotation motion, we have the moment of inertia, and this moment of inertia will play a very important role. And one more thing I want to say, according to me, the rotational motion is more complex chapter, because here all the concept that you have studied till now will be used. So just try to study this in a proper manner, attend all the classes properly. No matter your exam, in your exam there is a syllabus, properties of matter and all that. Ultimately in final exam there will be all syllabus. And you know very well, and I also know very well, we cannot just complete all the things at a particular time. At a particular time we can only complete one thing. Okay, so until and unless it is not necessary to leave, means to not attend the class, so please join the class.